Hi guys, so for this video we're going to discuss forward kinematics, and let me show you what are the differences of just parenting your object to a skeleton, or parenting it onto your object or mesh, and constraint parenting. Okay, so let's say we've decided, take note that in forward kinematics it doesn't have what do you call this, IK handles. So usually we use FK for mechanical object, or object that doesn't have any deformation to your object, or um, for example is mechanical or robotic, which has hard surface that you can, if you want to control your hard surface character and animate them without being deformed by the IK or the skeletal setup. So I just duplicated my mesh that I've been using. This is a multi mesh. It's not a one piece model. I just parented it to the hip. Okay, and then I just duplicated the skeletal setup that I created manually on previous video. Okay, now let's see if this will work for our for our forward kinematics. Okay, so I've checked on my joint if it matches the area or mesh that I want to control with my object. Like let's say for the shoulder, I want it controlled by this area. Okay, I think I mess up with the parenting. Okay. Let me undo that, because I tried and did some tests before I start recording my video. There you go. So let's try. Okay, now it's working. Alright. So I tested if the same rig will work for an FK. By the way, you can set up your character rig as both FK and IK. You can have a switch to turn it on and off. Alright, so let me check again some of the parts. Alright, now it seems to be working. So this is my controller. Again, if you want, you can turn on and off IK, FK. You'll just have to add switch here on your channel box to turn on and off the rig. Okay, now let me show you. Right now the entire arm is parented on the shoulder. Okay, and then the skeleton arm is parented on the shoulder as well. Now if I try to just parent, manual parenting or regular parenting my mesh to the skeleton, let me do that. Okay, so select the joint and hit letter P. Now if I try to rotate my shoulder, the rest of the shoulder or the rest of the left arm follows. Okay, now since I need to bend my elbow, okay, so let me check if I can have it bent or the lower arm will follow. It doesn't follow. So what I'm thinking is maybe I can parent the mesh with the joint for the elbow, and then let's hit P. Okay, and then let's try if it will follow. There you go, it follows. Okay, but let me go back to my root shoulder. Okay, seems to be working. Okay, but if I try to parent, okay, so this one is not working. Okay. Seems like it's working now. Okay, but there are times that when you do some transformation to your object, the rotation for the shoulder will lose, so it won't follow. The rest will follow, but the shoulder won't follow. There are times, or there are situations like that. Okay, I'm not sure why it's not like that right now. Okay, now let's try doing constraint. Okay, so let me go through. In constraint, we'll be able to retain the hierarchy for the mesh. Okay, unfortunately, when you do the parenting, regular parenting, on our skeletal system for forward kinematics, the problem here, you cannot switch on and off from inverse to forward kinematics. Okay, so the second part of this video, or the second part of this sample or demo, is I'm going to constraint parent, okay, the mesh to the joint instead of just regular parenting. So what is the advantage of constraining the mesh, constraint parent the mesh to the joint? Okay, the parenting, the original parenting of the parents, or the hierarchy of the parents, will be retained, but it will follow as if the mesh is parented on the skeleton, just like what we do here. Okay, the hierarchy for the mesh is intact. At the same time, it's following like as if you are as if the mesh are parented to the skeleton. So let's try. I'm gonna select this joint Q. Okay, constraint parent. Okay, so when you constrain parent, the translate and rotate will be controlled by our controller, which is the joint. And then I'm going to select the joint and constrain parent again. Now let me try and rotate this. Okay, it's working. Let me try and rotate this. It's working. Okay, it's almost the same effect as regular parenting. The only difference is you don't need to break up the hierarchy of the mesh. You retain the hierarchy for the mesh, wherein the legs are parented to the hip, the upper chest is parented to the hip, the head is parented to the hip, and so on. But unlike with the one that I parented with the joint, okay, as you can see, when I select the body, the left arm is not included in the selection. For me to have the left arm selected, I have to select the skeletal system. Okay, so if you don't want to break the hierarchy of your mesh, just like what we did with IK, okay, if you don't want to break that and you want on and off switch between FK and IK, then do not parent your mesh to your skeleton. Instead, parent constrain it to your skeleton. Okay, now let's try another thing. Okay, let's try parenting this to our mesh, to our joint. So this one, parent, okay, just like what we did on the left shoulder. Okay, and then parent. Okay, I'm not going to parent this one, but instead I'm going to constrain the mesh, constrain parent, and then constrain parent again. Okay, let's check what the difference. This, on the shoulders, we didn't skin bind them. Okay, so let's try skin bind. Okay, however, when I select the mesh, okay, I cannot select the left leg because it is binded or parented on the skeleton. Okay, let me try if I constrain, skin, bind skin. Okay, let's try again. Skin, bind skin. It's computing. Okay, let's try to rotate this. Okay, when we did the skin bind for the FK skeleton, okay, you lose the connection. Okay, now let's try with the regular parent. It didn't lose the connection because it didn't really binded to the skin because it's already part of the skeleton. So it considered the mesh as part of the skeleton and not part of the mesh. Here, since this is constrained parent, it didn't consider it as a skeleton, but it was computed as a mesh. Okay, so again, this is where the functionality of your skeleton will enter. Okay, so how are you going to what type of skeleton are you going, or rig setup are you going to use for your character? Well, it depends. You can have FK and IK. You can switch on, switch off the FK and IK, and also mix both. Okay, what are the scenarios that you can use FK and IK? So you can do IK for the mesh, the body, and then you can do FK for the let's say weapon, the sword. So let's say you're animating a character with a sword, holding a sword, okay, or holding a gun or some weapon, okay, or some object. So you can set the object as IK and then the body as FK and animate it according to its functionality. So with this, I'm just showing you what's the difference between parenting your object to a skeleton, or parenting your mesh to a skeletal setup, and not parenting it but constraint parenting it to the skeleton, and how it will respond when we skin bind. As you can see a while ago, this one is working, but when we skin bind, it's not working anymore. It's already detaching from my skeleton, but here it works. Okay, so those area that I didn't include on parenting onto my skeletal system, it acts like it's an IK setup. So there are deformation here on the chest area because I didn't parent the chest area to the chest joint. Okay, so this one is forward kinematics. When I rotate the lower arm, it doesn't deform. So it's a mixture of forward and inverse kinematics. So in this setup, I've already showed you the difference between the two. Then it's up to you. Depends on what usage are you going to apply this functionality to your object. So if your purpose is to have a mixture of FK and IK, then you can do so. Okay, it's either parent constrain it to your object but do not skin bind, or you just parent the mesh to the skeleton. Unfortunately, you wouldn't be able to select it with the body or the mesh, the entire mesh. So if you're going to select the entire mesh, you have to select the both the mesh and then the skeleton. Okay, because some parts of the mesh is already parented to the skeleton, while some parts of the mesh is still within the hierarchy of the mesh. Alright, so try to use the this functionality appropriately as needed by animation. Alright,